Did you know that water is known as a universal solvent? Its slightly polar nature allows it to dissolve many compounds into aqueous solutions. Hi, this lesson is on aqueous solutions. So, in order for a reaction to occur, a new substance must be produced with new distinct properties separate from the two reactants. Now, we can see this through observations such as an odor is produced, a phase change occurred, bubbles or precipitate formed, or there's been a new irreversible color produced. Now, this energy change can either be endothermic or exothermic, so it can release heat and become hot, or absorb heat and feel cold. And so heat or light could be produced, heat or light could be absorbed, both resulting in a temperature change, or even possibly a phase change. So in an endothermic reaction, heat is absorbed, like ice packs, and in an exothermic reaction, heat is released, like a combustion reaction. Solutions are homogeneous mixtures of substances, and together they are a solvent and a solute. The solvent is the substance which the solute dissolves in, and water is the most common solvent that forms aqueous solutions. Solutes are the substance dissolving, so the salt in the water or the sugar in the water, that would be the solute, what gets added to the solvent. In solutions, both the solvent and the solute can be in any of the three states. So there's metal alloys such as brass, where copper is heated to liquid form, zinc metal is dissolved into the molten metal, and then it's cooled back into a solid, forming brass. Where windshield washer fluid is an alcohol solute, where the water is the solvent, so that is in liquid form. Air would be a gaseous solution where there's a mixture of nitrogen, carbon dioxide, and oxygen. Water is a good solvent because it's a polar molecule, which means one end is more negative and the other end is more positive. So this allows the particles to be attracted to one another and towards other molecules that are non-polar. So the oxygen end is more negative, where the hydrogen ends are slightly more positive. So polar substances are good solutes and for all other polar molecules and for ionic compounds. So the water, which is slightly negative on one end, attracts the cation from the ionic compound, which is going to be positive, and the slightly positive end of water attracts the negative anion from that ionic molecule. So this is why ionic molecules will more easily dissolve in water. In an aqueous solution, water dissolves so many substances that pure water does not exist in nature because there are often things dissolved into it. Aqueous solutions are the most common and versatile of any solutions, and they are clear or transparent, but it does not mean colorless. So aqueous solutions can have a color. Solvation is the process of a solute dissolving in a solute. So we add that solute to the solvent like sugar to water. The polar molecules are going to attract the polar water molecules attract the opposite sides of the solute particles. The bonds holding the solute break down. And then the solute ions are separated and become completely surrounded by the solvent or water molecules. So the sodium chloride would be put into the water, the ionic bond would be broken down, and then the positive metal cation would be attracted to the negative end of the water molecule, and the negative anion attracted to the positive end of the water molecule. If the attraction between the particles of the solute is stronger than those with water, the particles will not dissolve. And a solid in this solution is called a precipitate. So this is where we have a copper 2 sulfate solution. And in hydroxide, the colorless sodium sulfate solution. So solid copper forms. Dissociation is the process that happens when an ionic compound dissolves in water. So that sodium hydroxide or sodium chloride molecule will break up into its cation and anion components. And the degree of dissociation depends on the solubility of the ionic compound. So a compound with low solubility, like calcium carbonate, is assumed not to dissociate to any significant amount. However, sodium chloride will dissolve. Dispersion occurs when a molecular compound is dissolved in water, but it does not dissociate because it does not have charged ions. Instead, it will simply dissolve and become an aqueous version of itself. So this is why molecular compounds are often non-conductive, because they do not form electrolytes in water. So because they do not form electrolytes, they do not conduct electricity. So for example, Sugar solution, sugar solid just becomes sugar aqueous. So salt would be a strong electrolyte because it completely dissolves. Acetic acid, a weak electrolyte, but sugar would be a non-electrolyte because it does not conduct electricity. So electrolytes are solutions that conduct electricity due to the presence of oppositely charged ions, so cations and anions. So conductivity is the ability for free electrons to move through a substance, and all electronic compounds that form solutions or dissolve conduct electricity. Strong electrolytes are when most of the solute dissolves, and so lots of ions are available in the water. And weak electrolytes are when only a fraction of the solute exists as ions, so there's less conductions and a weak electrical current can be tested. So the testing a solution for electrolytes involves the use of an ohmmeter or a multimeter. So the use of the positive cathode and a negative anode to complete the circuit will test if electricity will pass through that solution. So we can see if we put a light bulb test on distilled water, there's no electricity being conducted. A light bulb on sugar water, or this looks like milk, or a solid ionic. So this is a solid ion. So this would be solid salt will not conduct electricity. But then once we have salt dissolved in water, it will conduct electricity and that light bulb will turn on. So when we look at our solubility table, and this is in your data booklet, combination of the cations are highly soluble and will form strong electrolytes. So we can see that if we put most chlorine ions in a water solution, they're going to dissociate and dissolve. However, if we put most hydroxide ions into a water solution, they're not going to dissolve, except for the list of them above. So hydroxide, it'll say most don't dissolve, except for the following list. And for chlorine and fluorine and bromine and iodine, it'll say most will dissolve, except for the list below. And those ones are going to be only slightly soluble and will form weak electrolytes. So we're going to say that that mixture of ionic or molecular compound and water would form a solid. So lastly, we're going to look at water as an agent of chemical change. So using a solvent like water is a good way to facilitate a chemical reaction. So two ionic compounds have limited surface area to react because of the way their structures are formed and their ions are held in position. But by dissolving these two compounds in water before first mixing, the number of ions that can come in contact is much higher and a chemical reaction is much more likely to occur.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.